Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today's tutorial will focus on moment of inertia, specifically on how to compute using composite bodies or composite area. Right. In terms of the moment of inertia itself, I think we have covered in the lecture, for example, how it relates to the reality that we can see the shape of structures like this, like the I-beam, H-beam, etc. in a real world construction, right? So that relates to the moment of inertia concept and what is the impact in terms of bending, for example, right? So that's the concept. And in the last tutorial we have already covered how to compute or calculate a moment of inertia using integration. But for today's, because if you relate to the shape that we see in the structure just now, it is sometimes a combination of basic shapes, where in that case we do not need to actually integrate every time. So there's an easier way to compute, because the basic shapes, you have already the expression to straightway calculate what is the moment of inertia, and that will be the focus for today, right? So again, it will be moment of inertia calculated using composite bodies or composite areas. If you need the question that we will be covering in this tutorial, it is in the description box below as usual. So without further ado, let's go and solve our first question. We have the diagram on the left there. It is basically combination of a rectangular, right? And the dimension is all given. So the question says, part A, referring to the figure, determine the moment of inertia of the beam's cross-sectional area about the x-axis that has the origin located at the centroid C. Clearly indicate the equation used in your calculation. And part B, referring to the figure, determine the moment of inertia of the beam's cross-sectional area about the y-axis that has the origin located at the centroid C. Clearly indicate the equation used in your calculation. So basically part A and part B is, one is moment of inertia about x-axis, one is moment of inertia about y-axis, right? So it does involve what we call the parallel axis theorem. So in terms of the equation itself, so it is straightaway Ix equal to Ix prime plus a dy square. That is for Ix. And we'll focus on Ix first, because the question part A is about Ix, right? So that is the equation, and hopefully you have understood already what is the meaning of each of these from the lecture, right? So what is important to note is that you have to specify how you actually divide your area, right? Because that will have an implication in terms of what is the exact dimension for each area, etc. And the calculation throughout can be a bit different if you divide it differently, of course. But of course, the final answer is still the same, right? So let's try to do in two different ways, just to illustrate, right? So one way is, if you okay, how to do this? Okay, I put the diagram there first, and we'll do it like this, right? So if the shape is something like this, and you divide it like this, right? Let's say this is the first way I want to do it, right? So with this, all the dimension is, so this height is 50 mm. Okay. This width here is 5 mm. So this is 5 mm. So meaning that this left over here becomes 25 mm, right? 30 minus 5. And then this is 5. Okay. What else? Okay. So now we are dealing with the x-axis, which is somewhere here. Right, this x-axis. So we have to be clear about which axis you are calculating the moment about, right? Because the answer will be different based on the distance from the x-axis, right? From this, what we can see is, maybe I'll try to use a different color. So what we need is all the distance between the centroid of each area and the axis that we are considering, right? So for example, for this one, Okay, the distance that we have is 17.5. So this whole distance is 17.5. Okay, the ratio is not accurate, but okay. So based on that, if you focus on this one, the centroid is somewhere here, right? Okay, my axis is a bit off because my ratio, but hopefully you can still follow. This one is 25, right? That is 25. That's the middle of this height. So the distance between this and this, okay, it seems small, but 25 minus 17.5 will be 7.5, right? If you add, becomes 25, correct? So that is the distance that we need for this one. And this centroid here, right? So because this is 5, this will be 2.5. So the rest here is 17.5 minus this one becomes 15, right? So 15 plus this becomes 17.5. Okay, those are the distances that we need, right? Because when you want to calculate the moment of inertia, okay, basically there's two things. One is when you have two areas like this, so Ix total is just Ix1 plus Ix2, and let me label this as 1 and 2, right? So for each of these shape, we can use this parallel axis theorem to get Ix1 and Ix2, right? So if I redraw this in relation to, should I redraw or is this clear enough? Because I have a tendency to redraw to avoid mistake on my part, right? So if you take a look at this, for example, this element here, this area here, so basically you have this is x, this x prime. So you have the distance here, we have calculated already, that is 7.5. Oops. And then this is 50 and 5, right? And then for this area here, this is 5 and 25. And then x, and then x prime here, you have the distance of what we have calculated earlier, 15. Right? So that's the two shape that we have to consider, right? So basically, if I calculate straight away, right? So Ix, it should be equal to Ix1 plus Ix2, and each of this is Ix prime plus a dy square. So if I calculate here, Ix prime for this one, okay, things to note here is that in this question, it doesn't give you any table, so you have to already memorize this 1 over 12 bh cube, right? So basically, Ix prime for rectangular is 1 over 12 bh cube, right? So this one is it is assumed that you have used this a lot, that you do not forget this already, right? So normally if the question in the final is just having rectangular, combination of rectangular, so this will not be given. But if it will be triangle or circle, etc., you will have the table, right? So, and as we will see in the after this, the question after this. Anyway, so here 1 over 12 bh cube. So b is 5, h is 50, and then cube. Right now I'm calculating everything in millimeter, so the number will be quite big. Anyway, so 1 over 12 bh cube plus a is 50 times 5 times 50, basically 5 times 50, and then dy square. Dy is this distance between the two axes, right? So 7.5 square. That is for this part, for Ix prime plus a dy, Ix prime plus a dy square. And then for this one, plus 1 over 12 bh cube, so 25 5 cube bh cube, right? Plus a dy squared. A is 25 times 5, and then dy is dy squared. Dy is the distance there, 15, right? 15 square. Okay, and then it's straight away the answer. If you calculate this, then you'll get 531.25 millimeter to the power of 4. So the calculation is quite straightforward actually. If you, regardless of it is chapter 9 or chapter 10, because both we have composite area or composite bodies, the calculation tend to be very straightforward. So this kind of question, we do expect that you do not have any problem to solve straight away, right? Okay, so now we have shown how to solve using this equation, and if you divide it as such, right? Of course, you have another way of dividing the area. So hopefully I can write there and the glare is not that disturbing, right? So the other way of this dividing it is something like this. Okay, the original is something like this, but if you divide it as this way, right? Meaning you divide that way. So meaning that in terms of the distance, now it becomes, because this is 5, now the rest here becomes 45, right? And then this is 5, this length here is 30, right? Okay, so in terms of, okay, so x axis is still here, and this whole distance is what is given, 17.5, right? Now dy now can be different, especially for this one, right? Because right now, okay, we'll start with this one first, right? This one is straightforward, it's still the same, so this distance will be, is half of 5 is 2.5, hence what we have here is 15, oops, right? 17.5 minus 2.5, we get 15. This one at the middle here, right? The distance here is what? So it is half of 45, meaning 22, how to write here, 22.5, right? That's 22.5, right? So how to calculate the difference? Because this is 5 already. So 22.5 plus 5 becomes 27.5. Okay, this whole thing becomes 27.5. Okay, if I write here, this whole thing becomes 27.5, right? 22.5 plus 5. You have, if you minus 17.5, you have 10 here, right? Yeah. So dy becomes 10 right now. So if I redraw it, this diagram, it will be, so I have this one, 5 and 45. Dy here is 10, right, between x and x prime. And then for this one, this is 30 times 5, and then the distance between the two axes is 15, that one, right? Now, so as you can see, the details of the dimension is different, and dy is also different, right? So when you plug in, so I think there you have some glare, but you can, and unfortunately the area is limited, so I'll just write there, but you can just follow what I mentioned, and I think you know already what to do, right? So if you have ix here, it is equation ix1 plus ix2, and ix for each of this is ix prime plus a dy square. So here you have 1 over 12, 5, 40 cube for 1 over 12 bh cube, and then plus a dy square. So a is 5 times 40 times dy square is 10 square, right? And then plus over here you have 1 over 12, 30 times 5 cube plus 30 times 5, which is the area, times 15 square, right? And if you calculate that, you have exactly the same answer as this one. It should be, right? 94,531.25 millimeter to the power of 4. Okay, so that's how you calculate, and regardless of how you divide, whether this way or this way, the answer should be the same, right? So that's how you apply. Basically, when you divide the area, which is composite area or composite body, you'll have just to add up all the moment of inertia for each area, right? And then for each of this, for each area, you'll have this parallel axis theorem, Ix prime plus A dy square. So I have the habit to always illustrate as such so that we do not make mistake in terms of dy, for example, right? Because sometimes all of this distance you can make a mistake if you not clearly indicate something like this. So my suggestion is just a suggestion. You have a habit to illustrate everything so that when you yourself in the exam want to check, it's quite easy to follow what is going on, right? If you do not have this, you have to what is this? So even though I know many students have the ability to just from seeing the question, they can straight away compute the things, right? But in the exam, it's best to just spend 1 more minute to avoid mistake, because mistake can be very costly in terms of your marks. So we have calculated how to calculate the moment of inertia about x-axis. Right now we will calculate about y-axis. So in terms of the equation, so for Iy, it's just simply Iy prime plus A dx square, right? So in the lecture we have discussed why the equation will be like that, right? So because for Ix, the distance between the two axes is dy, right? For y-axis, the distance is x dx, right? So and also the same concept is applied. So you divide the area. So for example, if the first way of division is something like this, like before, so again we will have this becomes 5, this becomes 25, this becomes 5, this becomes 50 just now, right? What else? But now we are focusing on the y-axis, right? Because we will calculate Iy, right? So y-axis is here, right? Where it is 7.5 from the end, right? So this here is 7.5 millimeter, right? So based on that, if we focus on this area here, the y prime axis is here, where half of it is, this one is 2.5, right? So what remains here, 7.5 minus 2.5 becomes 5, right? So we have that distance here. In this case, right? So half of 25 is 12.5, right? Half of this is 12.5. So meaning that this whole distance here, 12.5 plus 5 becomes 17.5, right? So meaning that the difference here, when you have 17.5 minus 7.5, you actually have 10 here, right? Of course my scale is off here, but hopefully you get that. So if you redraw, meaning for the two areas, so meaning that for this area here, and then you have the axis and the axis here, y-axis, y prime axis. So the distance between the two is 5, right? And then this is basically 5 times 50. And then you have another area there where this is 25 times 5. And then the axis, the center here, y-axis here, the distance between the two is 10. That is what we calculated from above, right? So again, we have Iy equal to Iy1 plus Iy2, right? Meaning that Iy from here plus Iy from here, you get Iy for the whole thing, right? So we have Iy equal to, just add for the thing. For each shape, you have Iy prime plus A dx square, right? So Iy prime. So for hopefully you understand 1 over 12 bh cube or 1 over 12 hb cube depending on your axis, right? So now here you have 1 over 12, and then you have 50, and then you have 5 cube, right? And then plus A the area, 50 times 5, and then the distance here, which is 5, and then you have square there, right? Because the equation have square, plus for this one 1 over 12, and then you have 5, and then you have 25 cube, and then plus 5 times 25, and then you have the distance there 10, so 10 square. And then you can get away, you can get the answer straight away there. So it should be 25,781.25 millimeter to the power of 4. Alright, so again, if you do the calculation by the way that you divide the area is the other way, the answer should be the same as well, right? So if you use how to divide, you divide like this, right? So the difference is, now this is 30, this is 5, this become 45, right? And this is 5. Okay, so when you have the y-axis somewhere here, where the whole distance is again 7.5, right? The whole distance here is 7.5. Okay, my drawing is a bit off, so I'll alright, okay, this is 7.5, right? So for down here, for example, in the middle here, this one is 15, right? The middle of 30 is 15. So 15 minus 7.5, you get another 7.5 there. That's the distance. And if you have the axis of centroid for this one, the middle here is 2.5, meaning that this thing is 5. So if you redraw each of these, so you have something like this, and y-axis here, y prime here. So the distance is, right now is 5, that's the same. So this is 5 times 45. And then for this one, you have y and y prime. The distance now is 7.5. And then this is 30 times 5. Okay, so if you calculate IY, so 1 over 12, 45 times 5 cube, and then plus 45 times 5, and then the distance is 5 square. And then over here you have 1 over 12, 5, 30 cube plus 5 times 30, and then the distance is 7.5, and then you have the square. So if you add this, you should get the same thing, right? 25,781.25 millimeter to the power of 4. Right? So just to check, 1 over 12, 45, 5 cube, 45, 5 square, 5 cube, 537.5 square, right? So it's very straightforward as long as you understand, right? Make sure you understand the question asks about which axis, and then how to get dx or dy from the axis of the question to the axis of each shape, each area, right? Alright, so this is question 1 completed, both part A and B. Let's move on to question number 2. Okay, in this question we have on the bottom left the diagram of the area. So we have a combination of a triangle, a rectangular, and a circle hole there. The question says, referring to the figure, determine the moment of inertia of the composite area about y-axis. Refer to the appendix if necessary. So actually in the original question paper, the question is only just the statement of the question and then the diagram, and then at the back you have the appendix of the table shown there on the right side, right? So in the slide, I put everything there, right? So you have the table, you have the question, right? So as I mentioned in the previous question, if the question that you are given in the exam is just combination of rectangular, so you are expected to already memorize 1 over 12 BH cube, right? But if it is combination of triangle, circle, etc., so the table will be given. You just have to know how to refer to the table, right? Now, so for this question, the question only asks for IY, so we'll just focus on that, right? IY is IY prime plus A dx square. Right? So the area is basically how to divide the area is basically just considering the basic shapes there, right? So if I consider, basically you have three shapes, right? So we have the triangle, right? And then we have the rectangular, and then we have the circle. Okay, is this enough space? Right, so basically we have this area, right? So basically this plus this minus this, basically, right? Meaning that the moment of inertia of Iy is basically Iy for this one plus Iy for this one minus Iy for this one, right? Because this is a hole in the original diagram there, right? Again, so Iy is basically Iy, how to number this? Our triangle plus Iy rectangular minus Iy circle there, right? Okay, and then we also know for each of this shape it is Iy prime plus a dx square. So what we need is dx square, right? So this one is basically in terms of the dimension, this is 360 and then multiplied by 240 in millimeter, right? And then where is the axis? The axis is here. This is y-axis, right? With respect to the question. So y prime is here, right? Which is you have the ratio of 1/3, 2/3, right? So based on that, the distance between the two axes is 2/3 of this one, right? So 240, right? That is the distance between y-axis of the question and the y prime axis for the triangle itself, right? So we need that distance. For this case, the distance, the dimension is, this is 360 multiplied by 240, and then y-axis somewhere here, right? Meaning y-axis is here, right? So there's a distance. So if we consider y-axis to y prime axis, what is the distance? That distance there is 360 plus 180, right? Meaning 540, is it? 540. 3, 4. Yes, 540, right? Right, here. This circle here, we have y-axis here as well, and then y prime here. The radius is given as 90 millimeter, and the distance between the two axes should be the same here, right? This is 540 because the y prime axis is the same. Okay, so that is what the information that you have to be able to establish to use this equation, right? Okay, so I put it in drawing so that it's clear, right? And in the exam as well, I have a preference to draw all this. It just take 1-2 minutes and you will be clear about all the dimensions that you need. And when you want to check, as well as when the examiner want to check, it's become easier, right? So Iy is this plus this minus this one, right? So in this case, this. Alright, this is where we look at the table, right? So if you take a look at the table, for triangle, it's quite small. It is 1/36 BH cube. It is 1/36 BH cube, right, for triangle. So that is for x, right? Because the base is x, right? So when it is Iy, you have to be able to tilt it, right? So either you change become 1/36 HB cube, or you see the BH in this, meaning you see from that tilted 90 degrees. Look, this is B, this is H, right? So either way you want to understand it, as long as you get it correctly, right? So here you have 1/36, and then you have 240, and then you have 360 cube. That's from the, if you look at the table, you have 1/36 BH cube there, right? And then plus A is the area here, so half times 240 times 360, and then you have dx square. So dx here is 240, right? 240 and then square. Alright, so that's for the triangle. For the rectangular, so plus, so again 1/12. So in this case you have 240 multiplied by 360 cube plus area. So area is 240 times 360 times dx square. So 540 square. Hopefully you can see. I think my writing is becoming smaller because there's a lot of things to write here, right? Okay, so for this circle, so what is for circle? If you look at the table, it is 1 over 4 pi r power of 4. 1 over 4 pi r over 4 if you look at the table, right? So plus 1 over 4 pi r. R is 90, then power of 4. Is it? 1 over 4 pi r power of 4, right? Okay, this is negative, right? So it should be minus all this whole thing, right? So it will be minus here, and as well as minus here, right? Because it's minus the whole iy of this one, and iy of this one is iy prime plus a dx square, right? So area is pi r square, so pi 90 square. Dx is 540, right? So 540 square. Oops. Right, and then straight away you will get your answer. If you calculate, you'll get 2.145 times 10 to the power of 10 millimeter to the power of 4. This is if you use in millimeter, right? 2.145 times 10 to the power of 10 millimeter power of 4, right? Of course, if you use meter, then it will be quite a small number, right? Because this will be 0 point something, 0 point something, 0 point something, so you'll get 0 point something as well, right? So you can verify the answer. So the step of calculation is not difficult actually, right? So as long as you can divide into the basic shape and just calculate properly. I have a habit to make sure everything is very structured like this, so that especially in the exam, so that when you want to trace back, if you have the time to recheck, it's quite easy to check, right? This one, right? So do have a habit to have it quite in a structured way, right? So that it is easy to follow and check and notice if there's any mistake. All right. So that's this question. We move on to the next question. Okay, the third question here, we have basically the same idea of question, right? So we have the diagram quite similar but a bit different in terms of the dimension there. And then the question says determine the moment of inertia of the shaded area about y-axis, Iy. Clearly indicate any equation that is being used for the calculation, right? So now the thing is this. The concept, if you can see, is exactly the same as before, right? And next thing is, at the moment that I'm recording this, I haven't managed to calculate, to actually try to calculate this and the other question after this. But because it's exactly the same in terms of the concept of the question, so I don't think it's super important for me to actually show what is the final answer. I just show how it is being calculated. And even though the question asked only for Iy, so I think just in case you need to calculate for Ix, we'll just show how it is being done in terms of the initial steps, right? So that will be what we will be doing here, right? So even though the question says Iy, so we'll just do for what it will be happening for Ix and what will be happening for Iy, right? So in terms of the drawing, I'll put it there, insyaAllah. So the original drawing. So in terms of Ix, if you do Ix first, right? So Ix, the equation will be Ix prime plus a dy square, and as well as Ix equal to Ix1 plus Ix2 plus Ix3, etc. Or in this case, Ix triangle plus Ix rectangular minus Ix circle, right? So in terms of Ix, so what we have to relate to is the x-axis, right? So when we have the triangle, for example, okay, we'll divide it first, right? Triangle, rectangular, and then circle, right? So this is plus, this is minus. So the axis that we need to deal with is this one, right? So at the bottom here, so this is x-axis, x-axis, and x-axis. Okay, and the centroid of the shape, the respective shape, here is here, right? So in this case, this is 300, the base, and then is 200, the height here 200. So meaning that this height, this distance here between the two axes, between x-axis and x prime axis, is 1/3 times 200, right? Sorry if it's small, but I think you can get the idea, right? So it's 1/3 of this 200 height, right? So that will be dy. And this one, the centroid here, of course, this is, what is this? This is 350. So this length is 350. The height is 200. So meaning that this will be 100, right? And then this one with x prime here, so the distance will be again 100 here, and this radius for this question is 75, right? So given that information, so you can straight away use all the equation that we need, right? So for Ix, it is Ix this one plus this one minus that one, right? So we'll have, in this case, again 1 over, what is the equation? 1/36. So the equation from the book is 1/36 BH cube, right? So that is for x-axis, so we can straightaway use this one. So 1/36 times 300 times h is 200 in this case, 200 cube, and then plus the area is half times 300 times 200, and then you have that 200/3 and then square, right? 200/3 is the dy, right? And then for this one, so 1/12 bh cube, so 350 times 200 cube plus the area is 350 times 200, and then the distance between the two axes is 100, and then you have square there. For this one, again, what it is, 1/4 pi r to the power 4, right? So 1/4 pi r to the power 4, right? So again, this is minus, so minus 1/4 pi times 75 to the power of 4, and then minus as well because we have to minus the whole thing. So area is pi r square, so pi 75 square, and then the distance is 100, right? So we have 100 square there, right? So and then you can calculate straight away, right? So that is if you need to calculate for Ix. Okay, so that is for Ix. What about Iy? So Iy, if you just write the equation first, so we have Iy equal to Iy prime plus a dx square, right? And the idea is just the same. It's just that we relate everything to the y-axis, right? So we have the triangle. So the triangle actually in touch with the y-axis there, and then we have the rectangular where you have certain distance, and then we have the circle, right? So if we relate to the y-axis, so y-axis is here in this case, y-axis is somewhere there in this case, y-axis somewhere there in this case, right? So for this triangle, because this is 300, this is 200, right? Okay, my space is limited. Anyway, so the centroid is here, meaning that this distance will be 200, right? The dx square, because this is 1/3, 2/3, right? So 100 and 200 there. And this one, if you have axis here for the y prime, because this is what? This is 350, right? 350, right? This is 200. So and this distance here should be the half of this is what? Half of this is 175, is it? Yeah, 175, right? Becomes 350. And then the triangle here, you have that 300 there, right? So the whole thing becomes 475, right? And for this one, the distance will be 200 plus 300 becomes 500, right? 300 plus 200, right? So, and the radius is 75, right? So when you do IY, you want to calculate this plus this minus that, right? So it's just basically so this one is 1 over 36, so 200 times 300 cube, and then plus area, so half times 200 times 300, and then you have 200 square, right? For this one, so plus 1 over 12, so in this case 200 times 350 cube, and then plus 200 350, and then the distance is 475 square. This one, what is it? 1 over 4 pi r square. So plus, okay, so not plus, minus, because we minus this thing, so minus 1 over 4 pi, and then 75 to power of 4, right? 1 over 4 pi r to power of 4, and then minus the area is pi 75 square, and then you have the distance of 500, and then you have square there for dx square, and then you can calculate, right? So again, it's very straightforward, and if you get the idea already, right? So on this top here, for the ix prime iy prime, is basically switching this thing, right? So this is 300 200 cube, 200 300 cube, right? This is 350 200 cube, 200 350 cube, right? So this one, if you know how to do one axis, you should be able to know how to do the other axis, right? And then for a dy square or a dx square, as long as you can visualize what is the distance, it should be straightforward. It should be straightforward, right? Okay, so that is for question number 3. You can try and follow and calculate until the end, because the rest is just using your calculator. So I do not need to teach you how to use a calculator, right? You know how to do that. Alright, so moving on to the final question of the day. So this question states, determine the moment of inertia Iy of the shaded area in the figure about y-axis. Clearly indicate any equation that is used for the calculation. Right, so the question is again the same concept. You have the diagram, and then you have to find either Ix or Iy. Here the question asks for Iy, right? But again, because I think the concept is very much the same, it's just that you have to practice in terms of getting the right dx square, dy square, etc. Right? So I'll just show you how to start off the calculation, and the rest you can just practice on your own, right? So, and I will show you as well if the question asks for Ix and Iy, right? So we'll just see. Again, if you calculate for Ix, it will be Ix prime plus a dy square, right? So in this case, if we do for x-axis, so moment of inertia about x-axis first, so of course you still have this, you have the rectangle, you have the triangle, and then you have the whole of the circle there, right? So in terms of relating to x-axis, so x-axis is here, x-axis is here, x-axis is somewhere here, right? In terms of the dimension, so this is 300, this is 200, and then the middle here, obviously this will be 150, right? It's half of the 300. And then for the triangle, the base is, what is it, 150, the height is 300, right? And of course this will be 1/3, so it will be 100, right? It's 1/3 of the height, based on the ratio of 1/3 to 1/3, right? And then this will be, that is straight away, right? 150, right? So this is 150, where the radius is 75. Okay, so based on that, again, plus plus minus, right? Because the circle here is a whole, so it's minus. So if you calculate for Ix, so again, looking at back at the table, this should be just, you already memorize it, 1 over 12 BH cube. This one is 1 over 36 BH cube, right? Yeah. Okay, so 1 over 36 BH cube. This is 1 over 4 pi r to the power of 4. Right? So based on that, so in this case, so Ix become 1 over 12, 200, 300 cube. That 1 over 12 BH cube. And then plus area is 200 times 300. And then you have 150 square. Right? For this one, so plus 1 over 36 BH cube, so 150 times 300 cube, and then plus area half times 150 times 300, and then you have 100 square. And then here, so you have minus 1 over 4 pi 75 to the power of 4, and then you have minus pi r, okay, so pi 75 square, and then you have 150 square for the dy square. Right? So then you get your answer there. What about Iy? So if you have Iy equal to Iy prime plus a dx square. The same idea, is just that the distance to the axis you have to consider, right? So for the rectangular, right, and then for the triangle, and then for the circle, right? So if you relate to y-axis, so y-axis is here in this case, y-axis is somewhere at the distance there, somewhere at the distance there, right? So the dimensions, so again this is 200, this is 300, right? Okay, so at the middle here for y prime, so the distance will be half is 100 there, right? In this case, it is 1/3 ratio, so y prime there. So because the base is, what's the base? 150. The height is 300. So the distance between these two, okay, what is the distance? So here it is 50, right? Because 1/3 of 150. So 50, but this distance, meaning this distance is what? Is this distance, right? It's 200. So the whole thing, the distance is 250. Right? 200 plus 50. Okay. So in this one, this one is straightforward, right? So because the diagram already given you, this is 100. Right? And then you have the radius of 75. Okay, so if you want to calculate Iy, so again 1 over 12, 300, 200 cube plus area is 300 plus times 200, and then the distance 100 square. Alright, so this one, it will come 1 over 36. Okay, so here plus 1 over 36, you have 300, and then you have 150 cube, and then plus half 300, 150, and then the distance is 250, right? So 250 square. And then again this is minus, so minus 1 over 4 pi r to the power 4, so 75 to the power 4, and then also minus a dx square, so minus area is pi 75 square, and then you have this 100, then square, and then you get your answer, right? Now if you notice, if you have done this enough, you already know what to do, right? Because it is very structured in a way, and then straight away you are already familiarized with 1 over 12 BH cube. So what will happen here? 1 over 36 BH cube. So what will happen here? Meaning which is B, which is H. You already can, straight away you can relate how this is flipped with this one, right, etc. So that is the question for today. I think hopefully that is straightforward enough in terms of understanding what you need to do and execute it in a way that is structured enough, and to make it easier for you to check, to make it easier for you to calculate and avoid mistake, as well as do it in the optimum time, insyaAllah. Right, so that's it for today. Hopefully, because normally if the question about composite body or composite area, be it from chapter 9 or chapter 10, there's no reason to not getting full mark, because it's fairly straightforward, right? Fairly straightforward. You can try some other examples from the book for different combination of shapes or distance from the axis, etc. That's why I think I do like to draw something like this, so that because sometimes many students, they just refer to the original diagram and they just compute in their head, right? So it's okay if you do not make any mistake, but when we do, you forget to add this distance, etc. It's not worth the gamble, right? So just put it there, make it clear, so it is quite easy. When you want to check, it's already there, right? Because otherwise you have to go back to the question to recalculate. Is it correct? Is it correct? So that's the habit that I hope you have. You just train yourself, have a good habit, and then insyaAllah everything will be quite okay, insyaAllah. Wallahu alam. So that's it for today. We have completed chapter 10. We will go into another chapter in the next tutorial, insyaAllah. So until then, subhanakallahumma bihamdik, asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wassalamualaikum warahmatullahi wabarakatuh.